Here we go, guys. So, a big thing that you guys are constantly asking, when does this apply? How can you use this? Blah, 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 right? So we're going to start with some very basic ones. We're only going to do simple harmonic motion. So basically it's motion that is periodic in nature, such as oscillations of pendulums, the orbit of a satellite, the vibration of a tuning fork, right? Those things are best modeled by using sinusoidal graphs, so sine or cosine curves, okay? So we are going, huh?
Why are we in science class and shown?
Because I'm telling you where all this math falls into. The conclusion, okay? All right, so the graph here indicates the depth of water off a certain pier in Port Aransas, Texas, beginning at noon or March. Hey. Beginning at noon on March 19th, okay? So when we are looking at what we have here, it's telling us that our initial time here, this is noon. And the hours that follow are afternoon. So this is 1 hour later, 2 hours later, 3 hours later. It's not 2 o'clock, 4 o'clock, 6 o'clock necessarily, because once you get here, there's no such thing as 13 o'clock or 14 o'clock, okay? It is 13 hours after the noon. Make sense? Okay? But this is noon on March 19th, okay? Then the other thing is that pointing out is that your y-axis is your depth of water, your depth of the water from the sea level in meters. Okay, so here at noon, we are where? What is the depth of the water? 3, and we are above, right? Okay, so this is 3 meters above sea level, right? Okay, so that's how you read the graph. When you look at this graph, what shape is the data making?
A cup, cosine.
Cosine, a cup, a cosine. We can see that we have a cosine function, right? Does everyone see that? Okay. So now we're going to analyze it. So now they've collected their data and they're like, okay, let's talk about what we noticed here. So for example, they may ask, what time and date is the first high tide? When was our high tide? At 3:19 at noon, right? 3:19 at noon. Do we see that? That was our first high tide. When was our second high tide? Ooh, good job. I thought someone was going to fall for it. Why is it 3:20, Libby?
Because it's the next day.
It's the next day. What's the time? At 2 a.m. Good job. Because it's the next day. It's after midnight, right? All right. When was our first low tide? There we go. At 3:19 at 7 p.m. All right, so then it asks, how long does it take the tide to complete one cycle?
14 hours.
14 hours, good job. So that 14 represents our what? Our period, good job. 14 hours, and that is going to equal our T. Do I have enough information about this function, about this graph to create a function?
Yeah.
Yes, I do, right? I can create a cosine and a sine function because that's what we learned in 9.5, right? There's one of each, okay? We're going to do the most challenging one first, which is your sine. Why is it challenging to you guys? Because a lot of times when you don't see the full graph, you're like, oh no, I can't go any further. Hey, yes, you can. All right, so we're going to start off with the sine graph. So looking at what we have, our sine graph would be from here and then continue, right? So analyzing the sine graph and in general the cosine graph, we need to have all of our variables. We need our A, our H, our K, and our B, right? So what is the A that we're going to be using? 3. What is our B that we're going to be using?
1/14,
There you go. It's going to be 2 pi over 14, and that's because our period was what? 14. So this becomes pi over 7. Okay, and our K value in here is going to be 0. For all of our function, our K values are going to be 0 because they're simple harmonic, meaning that we're not moving up and down on the y-axis. Does that make sense? So our y-axis is our axis of our wave, so K equals 0. So now we can write our two functions. So what is our sine function?
2 sines pi over 7.
Negative 3 sine. Why is it negative? It goes down. And then what's the phase shift? What's the H?
Plus. No. Nothing.
How far am I from the y-axis?
Oh, 3.2.
Let's just say 3.5, guys. I don't know why y'all want to make it harder than that. Let's just be at a half. Let's just say roughly 3.5. Okay. So that's our sine. Let's do our cosine. So cosine is what? 3 cosine pi over 7. And what's the H for cosine?
Nothing, 0.
It's 0. So that's it. Okay, so here we're asking ourselves, it says, what is the depth of the tide at midnight on March 19th? I guess technically it's not midnight. It would be March, is midnight? That would be March 20th, right? At midnight, you're the next day? Yeah. Forget that I wrote 19, that should be a 20. You saw nothing? All right, so we're looking for this value, right? So it wants us to know if our x equals 12, what do we have? Is it quite at 2? We don't know. We're going to put in the calculator. So in the calculator, we have two options of solving this. We can plug in x for 12, right? Or we can look at a graph and a table. Does it matter which way we do it? It does not. So handy dandy calculator. I'm going to pull that out. I'm going to try if it lets me get to it. There we go.
Doesn't matter if you use sine or cosine.
It does not matter which function you use. Are y'all using, is anyone just plugging in? Or are y'all gonna do the graph? Yeah. So I'll model the graph. So if we have negative 3 sine, and we have pi over pi over 7 times x minus, that's not a minus, minus 3.5, close. I don't know why my calculator jumped across the page. I can then go look at the table, right? So I'm gonna go second graph, scroll down to my table at 12. And what does it say? Oh, it was not at 2. It's at 1.87. Yeah. You have to put double parentheses.
Oh, so
I put negative 3
cosine. That doesn't matter, right?
minus 3.5. No, it doesn't.
But I have to put the x in parentheses still afterwards.
As long as it's all, so for cosine in the calculator, it looks like this. You have 3 cosine, and you have second pi divided by 7. And I like to keep it safe, and so I double parenthesis. Just ensure that PEMDAS order is being followed. I don't know what thing you mean. I will come look. But as you can see, my tables are exactly the same. I will come and look at yours. Are you in
That's what
degree or radians?
I don't know. That's what I was thinking.
So go to your mode and make sure you're in radian.
Radian.
Okay, let me come look then. All right, so we said that how we are above so we're gonna be above 1.87 meters from sea level. So how do we feel about giving an X value and plugging it in? Easy enough? Okay, all right, now what if you're given the y value? So here it says find the first time the depth of the tide is 1 meter. So it's giving you your y value. So it's asking you, and y'all know I can't draw a straight line, so pretend this is just straight. That's pretty decent. So it's asking you at what points does this happen? When does that happen? Okay, it doesn't want us to find both. It only wants us to find the first one, the first time. Okay, so we're going to go to our calculator, and it works best if you only have one of the functions in. It doesn't matter which one you have in, but it works best to have both. So I'm just going to go ahead and delete my cosine one out. And in your second y, you're going to put the value that you want. And what value do we want? 1. We want 1. So we're going to put, we want to know when does y equal 1. Now, before I go to my graph, I'm going to change my table so that it matches what I have on my paper. So table settings, window settings allows me to change. What do we have on our paper? We have from -2, it looks like, -2 to how high? 14 on our x-axis. And then on our y-axis, we are -4 to +4. Do you guys see where I'm getting those values from? From our graph? Okay. So now when I hit graph, it should look like what's on my paper. We all know that the computer graph goes a little slow, but it's going to get there. I said it moves a little slow. All right, but here we are. So we want to find the intersection of this. So to find the intersection, we're pressing second calc. And you see where it says intersect? Did we all see that? We did second calc. So second trace is going to give us to the calc. I was here at graph, second trace takes me to the calculate page, and I want to calculate the intersection. So I'm going to hit 5, and it's going to ask you, you want to move your, I call it the little spider, your computer spider as closest to the side you want it to be at. So I want it to be on the left side, not on the right side. And you're going to literally just hit enter 3 times. 1, 2, 3. And it's like, here's your answer.
What's that say?
It says 2.742789. So we're going to put 2 and 7400ths hours afterwards. So we're looking at 2.74 hours later. So what rough time is that? That's at almost 2:45. 2:45?
Afternoon?
Yeah.
Oh, yeah.
Is it
Yeah.
2:45 almost?
Yeah.
Roughly? At 2:45 p.m. Because a quarter of an hour is 45 minutes, right? 0.74? 0.75? 3/4 of an hour? 3/4? All right. All right, how do we feel about word problems so far?
It's really fun.
Is it terrible? No, it's just coming all together. So this is why you learn all those skills to be able to apply it to real world situations. So tomorrow, we will do a couple more problems together, and then the rest of the period will be for you to work on your review. Got it? All right.